Hi everybody, this is Mr. Nolan, and this is our fourth and final video in predicting molecular shapes with the goal of being able to figure out the structure of a molecule based on its formula and the periodic table trends. Once again, if you have not looked at this video, periodic table trends, please go back and watch that. And by the way, you should really have a periodic table in front of you while you're doing these. I don't expect you to really memorize what all the bonds are for each atom. You should be able to use a resource for that. But I have some problems for you. These involve nitrogen. You'll notice they all involve nitrogen. And so before I go ahead and show you how to do these, please take a piece of paper, sketch them down, see if you can't figure these out based on what you learned in the other videos. Can you figure out how do I get these different molecules to come together? Okay, so hopefully you have paused the video and you have given these each the good college try. And I'll go through and I'll just kind of show you what would I do. How would I go through trying to solve these? So for the first one is one of the simplest molecules that you can have. It's just two atoms next to each other. We'll choose a nice pretty blue for nitrogen. And so I've got one nitrogen next to another nitrogen. And again, just to review, the reason that we know that is because there's a 2 next to that letter N, and so that means we have 2 atoms of nitrogen. So if I go ahead and just stick them together, what we find is that, great, we formed our molecule. However, if you go back and look at the periodic table, how many bonds is nitrogen supposed to form? 3. So you can find in that column where nitrogen is found, it's supposed to form 3. Now we're out of atoms. There's no way that we can add any atoms to this and to create bonds. So when you're in that situation, if you have no more atoms to bond, just increase the number of bonds. That's the only thing you can do. Our nitrogens now each have 3 bonds. If I look at the left nitrogen, well, there's 1, 2, 3 bonds. And if I look at the right nitrogen, there's 1, 2, 3 bonds. So this molecule is now satisfied. Let's look at number 2. I've thrown in carbon and hydrogen in this example, so this one's going to be a little bit more sophisticated. That's why these are advanced practice problems. So we've got our carbon. I like my orange from the last video, so I'll go ahead and use that. Like I said, carbon is usually found in the middle of a molecule, and nitrogen usually is too. If you're going to find nitrogen and carbon together, you'll never find, I shouldn't say never, but it's unusual to find them sticking off by themselves. Usually they're kind of in the middle. So let's go ahead and put carbon and nitrogen here inside, kind of toward the middle. And let's go ahead and just sort of array our hydrogens around the outside. Now we know that carbon's going to form more bonds than nitrogen will because carbon is in that group 4. And so our carbon's going to form 4 bonds and our nitrogen is only going to form 3. So I'm going to put the hydrogens sort of more heavily around the carbon than the nitrogen. So let's start bonding. Let's just start playing around with this. The carbon and nitrogen should be bonded, right? Because there's really no way to keep them in the same molecule unless these two are bonded. And let me just go ahead and fill in all the bonds that I can with hydrogens and see what happens. So this carbon is going to have 1, 2, 3, 4. All right, my carbon is now satisfied. 1, 2, 3, 4. And the nitrogen has got my 2 hydrogens attached. And so if we look at each one, the carbon has got my 4 bonds. The carbon's okay, and the nitrogen has also got 3 bonds. That's what it's supposed to have. And so our carbon and nitrogen are satisfied. And then each of our hydrogens only has 1 bond, and so that's also correct. You'll find that this is the only way that you can put this molecule together. This is called an amine group, this little nitrogen with 2 hydrogens attached. And so this is methamine, right? This is basically a methane molecule with an amine group on there, so we would call that methamine. Let's look at a slightly different one. We have carbon, nitrogen, but now we have 3 hydrogens. So if you watch the previous video, you might recognize what this is called. We have all the same atoms, but we've lost a pair of hydrogens. This means that we've introduced what's called a degree of saturation. And so that's just some extra information. But what we can go ahead and do here is we can actually try to create this, figure out how this works. So I've got my carbon, nitrogen, hydrogen. Carbon and nitrogen are usually going to go kind of toward the middle because they form the most bonds, so they end up sort of showing up in the middle. And then hydrogen is going to be around the outside because it can't form as many bonds. It can only form 1. So let's go ahead and bond the carbon and nitrogen together right away. And we only have 3 hydrogens to work with here. So we have to kind of figure out, well, how can we deal with this? So let's just, again, just array them around the outside, and we can figure out after that, how are we supposed to get them to bond? Well, if we go ahead and just start bonding them, what we observe here is that just in the way that I happen to have put them together, and actually let me do something incorrect first. Let me go ahead and do it like this. Okay, so our nitrogen is actually satisfied, right? It's got 1, 2, 3 bonds, but the carbon is not. The carbon only has 2. And by the way, we're out of atoms. So there's really nothing you can do here to fix this. The carbon, there's no way that I can get enough bonds on that carbon, so I don't think that this works. You could try double bonding these, but even then the carbon is still not in a good situation. It's only got 3. And the nitrogen's got 4, which we're not allowed to do. Okay, so the nitrogen is actually not good either in this situation. So I think that what we need to do is actually say, well, let's try this. Let's try bonding this one like that. Okay. So now we're at least closer to what we were to begin with. The nitrogen has got 2, the carbon has got 3. Again, we're out of atoms. We can't do anything. All we can do is add bonds. So let's try adding that double bond like we saw just a moment ago, and let's double check. Carbon has got 1, 2, 3, 4 bonds. Nitrogen has got 1, 2, 3 bonds. These are actually, this is it. This is good. This is the only way that we can arrange this molecule. And so we've got this double bonded carbon-nitrogen, and then these hydrogens on the outside. And so this molecule is completed. Let's go ahead and look at some inorganic molecules. These are molecules that don't contain any carbon in most situations. And so what we find is we've got 2 nitrogens, and then we have 4 hydrogens. And if you haven't noticed by now, you might recognize that I have color-coded these so that you can kind of see how many of each atom the number is talking about. So let's jump in here and look at number 4. This stuff is actually pretty cool stuff. This is called hydrazine. This is what they use to launch rockets into space. And we've got N2H4. With our nitrogens, let's go ahead, because the nitrogens form the most bonds, let's kind of put those in the middle. So I've got my N, and by the way, always use caps, because if I try to use lowercase n's and then lowercase h's, I can barely tell these apart. And so we don't want to do that. Make sure that you use uppercase only when you are doing these molecular formulas. So I got my nitrogens; those are all in good situation, good shape. Let me go ahead and start putting my hydrogens out here. I've got 4 hydrogens to work with. So let me just go ahead and put my hydrogens out here. Again, we can put the atoms out and then we can worry about bonds afterward. So my nitrogens have to be bonded. There's no way this molecule can work if my nitrogens are not bonded. And my hydrogens have to be bonded to the nitrogens as well. And we need to make sure that each nitrogen has got 3 bonds. So this nitrogen's got 1, 2, 3, and that nitrogen over there has got 1, 2, 3. So this is finished, right? Our nitrazine is completed. I want to, again, just to play devil's advocate, I want to try to do some incorrect bonding examples here. So let's say that you said, well, often nitrogen includes double or triple bonds, so I'm just going to stick a bond there. Well, we've now broken the rules here. Each nitrogen has 4 bonds, right? 1, 2, 3, 4, 1, 2, 3, 4, when they're only supposed to have 3. So this will not work. I have noticed that some people are tempted to do silly things like this. Wow, this is really not allowed, because each hydrogen can only have 1 bond. This is definitely not okay. We cannot put hydrogen in the middle of bonds like that. Hydrogen will only ever form 1 bond, not multiple bonds. So those are not allowed either. So that's nitrazine. Let's go ahead and do this last one. This is N2H2. Again, look at this. Same exact atoms, we just lost a pair of hydrogens. So that tells me there's probably going to be a double bond in there somewhere. So let's see. Let's go ahead and find out what's going to happen. Let's take our nitrogens, and once again, we're going to put those in the middle using caps, not lowercase. And let's bond them together. Those will probably be bonded together. And our hydrogen, we only have 2 to work with. Oh boy, we only have 2 to work with. So let's just go ahead and, put them around somewhere. Now, as I've drawn these, you'll notice right away, what is this hydrogen supposed to do? It's got 1 bond, But we can't form more bonds because that hydrogen's already got 3. This is not allowed. So I don't think that this is actually good the way that we have this. So the hydrogens, I think, need to be rearranged. Even though this nitrogen is satisfied, this one can't be. And so I don't think these hydrogens are in the right place. So I'm doing these incorrectly on purpose, just to kind of give you a sense of how do you deal with trial and error here. Let's try putting 1 hydrogen on here and 1 over here. Kind of like for our acetylene that we saw in the previous video. And let's bond them. Okay, so the hydrogens look like they're in good shape, right? Our hydrogens have got just one bond each. But our nitrogens aren't quite there yet. Our nitrogens have this one single bond, but each nitrogen only has 2 bonds. 1, 2. This one only has 1, 2. They're supposed to have 3, according to the periodic table. We are out of atoms, right? We can't use any more atoms to do any bonding, so that means that we have to add another bond. And so if you look carefully, each nitrogen, 1, 2, 3. This nitrogen, 1, 2, 3. They have the right number of bonds there in that nitrogen, in that molecule. So, considering that this is the last video in the Finding Molecular Shapes series, I hope that you have found it helpful, and that you have actually found this series of practice problems beneficial in trying to figure out how do I predict what a molecule is shaped like based upon the atoms that I find in the molecule and based on the ways that the periodic table says they ought to be bonded. So now that we've solved all of these advanced formulas, you should have no problem at all solving for these on quizzes and tests. So again, I hope that this series of videos was helpful. If you ever need to review this concept again, just go back and watch one of the videos, try to do the structures beforehand, and then watch my examples afterward. So I hope this video was helpful to you. Until I see you again, happy science.